Hi, in this presentation we are going to discuss about conceptual understanding of work, energy and power. The first one, what is work? Every day in our life, after getting from bed, we do many works like brushing, bathing, eating, running, walking, boarding the bus, reading, listening, so many things we do. And we say all these are works. But in physics, some of these are only works. Then how can we say this is physics work, this is non-physics work? Which are measurable in the real life, or which are measurable works in the real life, those are the works in physics. Now, how can we work? How can we measure the work? Let me explain. There is a block of mass m. It is resisted initially. Now there is a force acting in this direction, making an angle theta with the horizontal axis. Then this body of mass m travel in right side direction. Therefore its displacement is s in the right side. Then we say that this block m has done some work. So work is the product of force and displacement in the direction of force. So force, okay, capital F. Displacement, yes, but I mentioned in the direction of force. That means the displacement should be in the direction of force. Then we can say it's work done, or else force should be in the direction of S. Then we say the work is done. So therefore work is Fs into cos theta. This is the formula for the force. And work is a scalar quantity, even though force is a vector, displacement is a vector, because in mathematics we say that the two vectors, if you take the vectors dot product, is a scalar. So work is a scalar quantity, and work's SI unit is joule, and 1 joule can also be written as Newton meter. Why? Because force SI unit is Newton, displacement SI unit is meter. So therefore 1 joule equal to 1 Newton meter also. But whenever you write the unit of work while doing the calculation, it is recommended to write the SI unit is joule, capital J. Now here comes the situation that how did we get Fs cos theta? Let me explain you. Force make an angle theta with S, and force is a vector quantity, and when the vector quantity make an angle theta with the horizontal line, then vector resolution comes into place. That means force resolve into two components, along x-axis and along y-axis. So let me draw for you. This is y-axis, this is x-axis. So along x-axis force is F cos theta, along y-axis force is F sin theta. So if you see here, so along x-axis it is F cos theta, along y-axis F sin theta. And as I mentioned, force and displacement should be in the same direction. That's why the work done is F cos theta into S. F cos theta into S can also be written as Fs cos theta. And this force formula can be used whenever the force is making angle, some angle with displacement, or else displacement making some angle with force. Let me give a small example for you. Suppose theta equals to 30 degrees. That means the force is acting on the body. We make an angle 30 degrees with displacement axis. Then what is work done? So work done W equals to force F into displacement into cos 30. So here you should know the values of trigonometrical values of sine and cos to complete the calculation. So which is equals to Fs cos 30. Cos 30 is nothing but root 3 by 2. So root 3 by 2. So your answer will be root 3 Fs, root 3 Fs divided by 2 joules. That is the answer. See here, take one more case. If theta equals 0 degrees, that means W will Fs cos theta. So we can write W equals to F into S into cos 0, as theta is 0 degrees, cos 0. Now cos 0 is 1, so the value becomes F into S. So this is called maximum work done, because here force and displacement both are parallel, because theta between them is 0 degrees. See here, the theta between force and displacement is theta, but when the theta becomes 0, force and displacement both are parallel. So hence we can say force in one direction, displacement is also in the same direction. So both are parallel, and both are parallel, W equal to Fs cos 0, where that becomes Fs, which is the maximum work done. It is. So max work done. One more case study. If theta equals 60 degrees, what is the amount of work done? So let me write, which is W equals to F into S into cos theta, cos 60. So cos 60. And here the cos 60 value is F into S into cos 60 value. Cos 60 value is 1 divided by 2. And so your work done value becomes F into S divided by 2. So in this way we can calculate the amount of work done if angles are given to us. But remember, force displacement should be in the same direction. If you ask a question that what is the amount of work done in F sin theta direction, and the answer is 0, because in F sin theta direction there is no displacement along F cos theta. So therefore in F sin theta direction the amount of work done is 0. So always you need to see whether displacement is there in the particular direction or not. If there is no displacement, work done is 0. Now see this question. There is a block of mass 2 kg, experiences 2 newtons of force with an angle 60 degrees with the displacement S. Then calculate work done in the direction of S. So as you know the formula, W equals to F into S into cos theta, and here theta is 60 degrees. So therefore you can write like this, equals to, what is the force value? 2 newtons, 2 into displacement. Displacement is not mentioned here. For example, say displacement is 4 meters. So 4, let me write here, displacement which is equals to 4 meters equal to 4 meters. then comes here, equals to force is 2 newton, 2 into displacement is 4 into cos 60. Cos 60 is 1 divided by 2. So the answer is 2 get cancelled. So the answer is 4 joules. So in this way, if a value is given to you using the work done formula, you can calculate the amount of work done by the body. Now see this numerical. There is a ball of mass 200 grams and which is lifted up to a height 3 meters, or you can say it's thrown up to a height of 3 meters. Now you can calculate the amount of work done in lifting the ball to height 3 meters. So the work done formula, W equals to F into S cos theta, or cos angle, I can say theta, okay. But you need to see that what is the angle here. If you observe carefully, there is an angle, and which side the force is applied to move up, body is also moving in the same direction. That means force and displacement both are the same direction, hence the angle is 0. When the angle is 0, if you recall, earlier I told that the work done is W equals to F into S. Okay. Now coming to the value of force. What is the force value? Force value is not given, but you need to know that here the body or the ball which is having weight in the downward direction, this weight, and this weight which is equals to, what is the weight formula? Mass into acceleration due to gravity, and this value is mass is 200 grams. Please convert it to SI units. 200 by 1000, which gives in kgs, and this is 0.2 kg into g value 10 meters per second square. So the weight formula becomes the weight value becomes 2 newtons, and this is nothing but force, because how much of weight you're acting downward, the similar amount of force you need to apply upward direction to lift the body up. So therefore the weight acting and the weight of the body which is equal to the force used to lift it up. So weight is nothing but force here. Now come back to here. So the force value is 2 Newton into how much the displacement? Displacement is, don't think always horizontally. The height moving up, the height going down is also displacement. So here the displacement is 3 meters, so 3. So the answer is 2 into 3, 6 joules. Here a small important information is there. So here we have calculated the amount of work done to lifting the body up. But you know, this amount of work done is also called potential energy. And what is potential energy? In the next coming slides we are going to discuss.